All right, good morning, everybody. Welcome again to yet another lesson for the STEM Lockdown Digital School. It's always good having you guys and teaching you guys and also getting your responses. This is Natural Science Grade 6. Just to remind you who I am, once again, I go by Karabo Fiona Khashani. My Instagram handle is KB_Khashani. And on Facebook, Karabo Fiona Khashani. All right, let's get into it, guys. Thank you so much for those that have tuned in. I see some of you are slowly coming in. Awesome. So let's get right into it, all right? All righty. Okay, so today's lesson, we are going to discuss what it means if something conducts electricity. So that word conduct is very, very important. We are going to discuss what is the difference between an electrical conductor and an insulator. All right. We are also going to discuss why insulators are important. All right, so just before I move on, yesterday you got some homework and I got responses from 2 students this morning. Thank you so much for sending in your work. I do understand that for some of you it may be hard, to send stuff in because of signal issues or, just one of those problems and technical glitches. I do understand. All right, but for those of you who have sent me your work, thank you so, so much. You can still do your homework and you can still send it to me and I will definitely still have a look. So again, thank you to all those who did their homework and I'm actually going to show you what I have received from them. All right. So firstly, this is work done by Mohumo. And Mohumo, I think you are in the session today. Yes, you are. Awesome. Thank you so much, Mohumo, for turning in your work. So basically what Mohumo did for us, he created a little simple circuit for us. He's got a switch, a light bulb, and a battery. And he just made a very simple circuit. Awesome stuff, Mohumo. And he also drew his house plan and all the light bulbs in his home. Now, as you can see there, I didn't count the light bulbs, but there's a lot of light bulbs. All right, so thank you so much, Mahumo, for that. But the only problem with this is we need to show the wires. All right, so with Mahumo, if you look at his light bulbs, I'm circling one. Some of his light bulbs look like they are just hanging in space. Hey, Mahumo. So remember to always include the wiring to show the wires. All right. So I'm just going to try and do that with my pencil now just to show you how you could have added some wiring. So you could have maybe just added something like that to connect to the arrow, to the wiring. Maybe connected that one to there. All right, so basically you could have just added some wiring to make it seem as though your light bulbs do have wiring. All right, so anything close to that would have been 100% correct. Remember, this isn't a perfect drawing. Electricians do this a whole lot better than we can, all right? So this is just to show you how Mohumo could have connected his wiring. All right, so basically just connecting all the light bulbs to the wiring. So maybe that one we can, oopsie, do something like that. Oops, sorry guys, man, it's hard. All right. Oof. Okay, that's just an idea of how Mahumo could have shown his wiring. But nonetheless, Mahumo, thank you so, so much for doing your work. It was great, and I see that you have tried. The only mistake that you just forgot was just to add the wiring. But nonetheless, this was a perfect drawing. I can see you used a ruler and a pencil. I can see that you've separated your bedrooms and you've got all your switches. Some of them are open, all right, meaning the lights were off. Awesome stuff, guys. Awesome, awesome, awesome. All right. Thank you all for that work. Alrighty. Then we also received from work from Vutadi. Thank you so much, Vutadi. So he did his circuit. As you can see, he made it like a border, which is extremely creative. Well done. And Vutali says, my home has 17 bulbs and 10 switches because at the sitting room, a switch shares 4 bulbs. Very good. The kitchen room, a switch shares with 3 bulbs at the bathroom, and a switch shares 2 bulbs at the main bedroom. 4 bulbs, each of them at the garage, and they share 2 bulbs, and outside rooms share 2 bulbs. So now we know that with Butadi's home, there are lots of light bulbs that share the same switch. All right, so he just did a little square, which is also 100% correct, just showing how many light bulbs and how many switches you got. Thank you, Butadi, for that. In fact, I just got his literally a couple of minutes ago, so thank you, thank you. The rest of you can still continue to send me your emails and your pictures so that we can have a look as to what your home looks like. All right. All righty. Let's move on. And I see Mahumu said she's a girl. I am so sorry, Mahumu. I apologize for that. You know, sometimes, especially with African cultures, Mahumu could be the name of a girl and a boy. Like I've got a friend whose name is Mahumi, and it's a boy. But anyway, thank you, Mahumu. I am so sorry. All right, cool. So this is basically just something I wanted to show you, just to give you a deeper understanding of circuits and lighting. Now, if you look at this picture over here, it's basically a house, and we can see the top view and the side view of the house. Now, the red lines that you see show the wiring of the home. All right, so it just shows how, if you look over here, ceiling rows C, 1 light bulb, and as you can see, the switch over there, but it's obviously connecting to all the other ones. All right, a lamp in ceiling B and ceiling A. All right, so basically, and then lastly, you've got your fuse board where you could actually just, you know, like a main switch, where you switch off all the lights if there's a power failure or something like that. So this is just showing you exactly how electrician is done in homes, and how, you know, someone who comes in to fix the light bulbs would do and sort out the wiring. Now, there's a lot of wirings in your home, but we just cannot see it, all right? Some of them obviously are covered in plastic, you know, the special plastic that they use up in the roof, and we cannot see the wiring, right? But when an electrician comes, he or she would know where to go, where this connects to, etc., etc. All right, so it's mainly an electrician's job to do wiring and connecting lights in the house. All right. All right, so here's my little drawing. All right, here is mine. This is my light bulbs in my home. I've got a very small home. I've only got about 9 lights. Each light has its own switch, actually. Obviously, this is not exactly what the house looks like. It's not exactly a rectangle, but I mean, if an architecture had to come in, an electrician, they would draw like the rooms and the design and all sorts. So I just drew a box just to make it easier for you guys to understand. I did draw this during the day, so obviously all, no, I actually drew this, well, I actually made it that all the switches are off, so none of them were lifted up. All right. So this would be a switch of all the light bulbs being on, because all the switches are closed switches, right? None of them have been lifted, right? But if it was to be lifted, and if I had drawn it, if one of the lights were on, we know that it would have been something like that, lifted up like that, if the lights were on, right? Just not with that line in the middle. This in the middle here would not be here. The switch would just be open. But with me, all of them were on. All right, so this is just an example of what I did, and this is just a recap from yesterday's lesson about symbols, switches, light bulbs, and how to draw your own circuit. All right, I hope you guys understand that. Should you need more information or you just need more clarity, please do let me know. And remember, always just send me messages in your Q&A and I will attend to them. All right, and I will answer you as best as possible. All right. Okay, let's move on. All right, so we are going to discuss conductors. So today we're discussing conductors and insulators. Now, just by looking at the picture that I have for you on the bottom left, what is your understanding of a conductor? What would a conductor be? I'll give you a couple seconds just to answer me in your Q&A. By looking at that picture, what is your understanding of a conductor? What is it? Remember just to type in your Q&A. By your understanding of that picture, what is it? All right, I'll wait for your answers to slowly come in. I see Karabo saying something that electricity can pass through. Very good. JD, all right, thinking of metal. Oloetu says a producer. All right, maybe you can just specify what exactly you mean by that, but thank you. All right. Anything else by that picture? What is it? What do you see? A lot of you are on the right track, something that electricity can pass through. All righty. So for you to categorize good electrical conductors and insulator. Now, a good electrical conductor is a material or a substance that allows an electrical current to pass through it easily. We call the ability to conduct conductivity. So for electric current to flow through, that ability is conductivity. Now there are conductors. Now all those pictures that you see at the bottom, we've got brass, aluminium, iron, copper, all of those are considered to be good conductors of electricity, meaning electrical current can pass through very easily. All right. Hope you've got your notebooks and your pens and you're busy jotting down the important facts. All right, so conductors, electrical current can pass through easily. Now, electrical conductors are usually metal. Someone said metal, JD, thank you, because metals generally have high conductivity. Copper is one of the best electrical conductors, and this is why it is the most common material used for electrical wiring. Now, one day, if maybe you've got a wire that is damaged or there's no plastic covering around it, and sorry guys, I think I lost you for a second there. All right, oh, we're back. All right, cool. So, you know, if you've got your brother or older sibling or father, they just want to check the wiring of the kettle or the iron or the lamp, you'll actually see that the wiring is mostly copper. So we know that copper is a very, very good conductor of electricity. Electricity can actually pass through. All right. We've got Anonymous saying that conductors conduct electricity. Very good. Shakira, it conducts electricity. Shakira says it's all metals. All right. We've got Mashodi, something that conducts a substance. Anonymous, they are materials that they use to make wires. All right, so all of you have a good idea. And Duvo says a conductor is a material that can conduct electricity. Bilentle, a conductor, something that electricity can flow through. All right, so most of you have an idea. We're talking metal. All right, so anything that electricity can flow through. And all of you seem to have a pretty good understanding of what a conductor is. All right. Now, gold and silver are even better conductors. Now, we thought copper was the best, but gold and silver are even better conductors than copper. But they are very expensive and only used sometimes. I know for sure that my home is not wired with gold and silver. My entire home is wired in copper. I actually have never experienced or seen wiring that's been made by gold or silver. If any of you have, actually, maybe you can let me know in your Q&A. Maybe your homes are wired with gold and silver. That would be really interesting. Maybe just tell us, what does it look like if you know, and what the difference would be between gold and silver or copper. All right. But I know that a very common one is copper, but of course there are homes that could be wired with gold and silver, all right, because it's just a very, very, very good conductor. All right, when two conducting materials make contact, electricity can pass through them. Our bodies are also good conductors of electricity. This means electric current can easily flow through you and into the earth, giving you a shock. Now, that is why sometimes you might find if you decide to, well, you shouldn't, but I mean, we've got some really naughty children who would decide to put their finger inside a socket. And doing that will cause you to have an electric shock because current is flowing in your body, right, and into the earth, because our bodies are good conductors, which is why it is not allowed and you're not supposed to be putting your hands inside a socket or touching wiring that is not fully covered in plastic. The wiring on our kettle, toaster, microwave, heater, they are all covered in either a black or a white, very, very hard plastic to protect us. All right, so we shouldn't be touching bare and open wires or putting our fingers inside a socket because our bodies are very good conductors and you will be hurt, right? You will get hurt. All right. I think Njabula saying that a conductor is a substance that can conduct things like us humans. There we go, Njabula. Very good. All right, awesome stuff. Right. Right then, just like I said, now that is why we cover conducting wire with insulating materials, like the plastic around extension cords. I hope you all know the kind of plastic I'm talking about, but every wiring that you have in your home, specifically your extension cords, kettle cords, cell phone chargers, they are all covered with plastic. This is because we want to protect ourselves from being shocked and prevent the electrical current from passing to other conductors. All right, so basically that is just what our conductors are. And we actually have a good idea of examples of conductors, just like in the picture over there: brass, bronze, metal sludge, steel, aluminium, cast iron, copper. Now we know that silver and gold are also very good conductors. All right, guys. Are we all good? Are you all understanding so far what conductors are? All right. All right, guys, let's move on. Just gave you a couple seconds just to have a look at that and just maybe copy down what you still need to. And we're going to move right along. All right, now let's discuss some more. Now, conductors, some materials conduct electricity are called conductors, all right? Most metals, especially copper, conduct electricity. A material that allows a path for an electric current to flow is called an electrical conductor. The material conducts electricity. Some materials conduct electricity and some do not. Conductors are made of materials that electricity can flow through easily. These materials are made up of atoms whose electrons can travel freely and easily through them. This is just some more information about conductors, but we know now that a conductor is a material that allows electricity to flow through. Right, most metals are conductors of electricity. Now, copper. Copper is the most common material used for wiring. Silver is the best conductor, meaning that it is material which makes it easiest for current to flow, but silver is expensive and so very rarely used in wiring. So it's very rare to find wiring made of silver, all right? But we do know that silver is a very good conductor, way better than copper. Gold does not rust. It is expensive and only used when high quality contacts are needed. So for all those expensive, high contacts, that's when gold could be used, and we know that gold does not rust. Then there's aluminium. It's not a very good conductor, but sometimes it is used where weight is a consideration. It is not as heavy as copper. So we know that aluminium is a conductor, but is not as good as copper. And also it's not very heavy, whereas copper is just a lot heavier than aluminium. Right, so these are basically the most common conductors of electricity. All right. Now let's discuss insulators. Now, by the picture that you see at the bottom, what would then be your understanding of an insulator? What are insulators? All right, I see JD saying gold is used in rockets. That is very, very interesting. Hey, look, I just learned something new today. Thank you, JD. Actually, they need to be covered in plastic so that you don't get electrocuted by the plug, 100%. All right. What is your understanding by insulators? I'll give you a couple minutes just to have a look at that. All right, so while you give it a thought as to what is your understanding of an insulator, I will just move on and read. All right, now insulators. Some materials do not conduct electricity and they are called insulators. So now we know that insulators are actually the opposite of conductors. Insulators do not conduct electricity. Most non-metals, such as plastics, do not conduct electricity. So all the non-metals, they don't conduct electricity. Insulators are non-conducting materials that do not easily allow current to pass through them. This does not mean that current cannot pass through them at all. For example, we generally consider air an insulator. However, lightning can cause electric current to pass through the air. That's how you might find that lightning might strike a tree, even though there's air between the lightning and the tree, which air is not a conductor, but the lightning can still cause an electric current to pass through the air. Lastly, similarly, rubber gloves and shoes will protect you from mains electric current, but not from lightning. Examples of insulators are plastic, rubber, and wood, as well as all the other pictures that you see at the bottom. Now, just to give you a little story, so when I go visit my mother, she has a stove, like a very big stove. But for some strange reason, you cannot use the stove if you are barefooted, because if you touch the stove, so if you touch the pot that is on the stove and the stove is on, you actually get a shock. So you always have to wear shoes when cooking on my mother's stove, because if you don't wear shoes, it just shocks you. And that's probably because there's some wiring problem happening, or maybe it's just too old. But that's just an example of the difference between wearing rubber shoes to avoid that shock. So whenever we cook at my mother's house, we all know that you have to wear shoes. All right, for some strange reason, if you don't wear shoes and you touch the pot, there's a little shock that goes through you, which is really not a nice feeling. All right. All right, I see Nduvi saying, materials that cannot conduct electricity. Insulators stop electricity from passing through them. All right. JD says, something that does not conduct electricity. Mahlodi says, ma'am, how does a tree conduct electricity if wood is an insulator? Very, very good question. It's actually coming in the next couple of slides and you will get your answer, Mahlodi. Thank you so much for that answer. We will address it in the next slide that is coming shortly. Caleb says, things that cannot conduct electricity. All right, awesome, guys. Keep those answers coming in as to what you understand by insulators. All right, so just have a look out for that answer, Mahlodi. It is coming. All right. Now, what is the importance of electrical insulators? Why do you think electrical insulators are important? In your chat, why do you think electrical insulators are important? In your Q&A, why do you think they're important? So this could be plastic, wood, that Mahlodi mentioned. Why are they important? I'll just wait for your answers, just a couple more seconds. All right. Okay, I'll give you a couple more time. In the meantime, I will read. All right, now think of electrical wires that you use in class for the activities. Would you think why do you think they are covered in plastic? So again, just like the plastic that covers cable cords, lamp cords, kettle cords, why are they covered in plastic? So we did talk about obviously some safety issues around the plastic. All right, I see Anonymous saying, ma'am, there are some houses in the rural areas that have wheels on their roofs. I'm sure you mean tires. All right, yes, very, very good. Actually, you're 100%. So you actually might find that homes, especially homes that have been made by corrugated iron. Now, you remember now, iron is already a conductor. So if there wasn't a rubber tire, the chances of that house being struck by lightning are very, very high. That's how you find that they've put tires on the roofs. Also because of just the weight that doesn't fly away, but mainly because iron is a very, very, very good conductor of electricity, and to avoid being struck, the tires are put there. All right, very, very good question and a very good point. Thank you so much for that, Anonymous. All right. The plastic is an insulator and therefore prevents you from getting a shock. The plastic coating acts as a barrier that prevents you from getting a shock allowing you to handle the wire when the circuit is on. Electrical insulators are also used in other places. Now, have you ever looked at power lines or telephone lines? You will see that the poles that carry the lines are sometimes made of wood. Wood does not conduct electricity, so the electric current can therefore not get from the wires into the pole. So we're slowly coming into your answer, Mahlodi, very, very slowly. You'll see the answer coming shortly. Sometimes you will also see little white or colored caps holding the wires as in the photo below. All right, just on the left. These caps are made of ceramic, which also does not conduct electricity. Alrighty, now please tell me, by looking at this gentleman over here, clearly look, he's got live wire, he's got wire all wrapped around him, and it seems to be that it's copper. Now, how do you avoid getting an electric shock? How can I avoid getting an electric shock? Please tell me. All right, I see a lot of you saying that plastics, they protect us from electricity and electric shock. Thank you, Ndovu. Anonymous, to make sure that you don't get shocked or an overload of electricity to pass through your home. Jabulo, so ma'am, when they get electrocuted, they don't pass through the metal. Jabulo, I'm not sure I understand your question. When they get electrocuted, they don't pass through the metal. Please just help me understand it a bit more, Jabula. I think I'm really struggling to understand your question, but thank you so much for asking questions though. All right. So please just also address the answer to how can we avoid an electric shock? All right, JD, ma'am, does leaves conduct electricity? Now, remember, now leaves conduct water. Not conduct water. They contain water. Just as much as humans, we have about 60% of waters in our bodies, which makes us good conductors of electricity. Now, just as leaves and just as the process of photosynthesis needs leaves, takes effect in terms of conducting electricity. All right, so Oloiti, don't touch wires, very good. Anonymous, you can't touch wires with naked hands, very good. Ndovu, by touching an exposed wire. Mahlodi, you must make sure you call an electrician to fix the plug or buy a new one. Shakira, put an insulator around the wires and don't play with wires. And we've got Oloiti saying stay away from wires, very, very good. All right, so let's not take a chance. We need to follow these do's and don'ts for our safety. First thing to do is to see that all unused electrical, so seal all unused electrical outlets. So all the outlets that you're not using, they need to be sealed. All right. Throw away or repair items that have damaged cords. If you are using a kettle that has a cord and you can see the wire, that needs to be repaired. Also, before you repair an electrical appliance, remember to unplug it. Imagine fixing a kettle with the plug in the socket. Hey, not a good idea. And only plug only one high watt appliance at a time to avoid overloading. This happens in many homes that one plug has so many appliances attached to it. TV, heater, charger, laptop, this and this and this. That's an overload and it actually causes it to overheat as well. So don't put too many plugs in one socket, all right, because it does overload it. All right, so just plug in only one at a time, all right. So what mustn't you do? The don'ts. Don't pull a plug out with its cord. So don't just pull the cord. You need to pull the actual head of the cord. Don't touch electrical wires with wet hands. That's another reason why trees are considered to be conductors, even though it's made of wood, is because trees also contain water. Now, water and electricity obviously do not get along. All right. Do not put your fingers or metallic objects in electrical outlets. Not good at all. And obviously don't use any kind of electrical appliances close to the water. I mean, you might find that some people would take a nice hot bath and they have charged their phone and they are using their phone in the bathtub while charged to the cable. That's not a very good idea at all. All right, not a good idea. Anonymous says if you touch an uninsulated wire, you will get shocked. Also, if you touch wire with wet hands, very good. Do not play close to wires. Hlengi, don't hold wires with wet hands. Njabulo, stay away from electric wires. Bunke says always use dry hands when handling cords. Very good. Caleb, don't play with or near wires or electricity. Anonymous, wipe your hands before you touch. And Gamo says don't wires while it's raining or when someone is cooking. Very good, right? Don't use wires or touch the wires while it is raining or when someone is cooking. All right, now I want us to give this a try. And I would like you to tell me, is a rubber band a conductor or an insulator? Is a rubber band a conductor or is it an insulator? Is a rubber band a conductor or an insulator? Let's see what we have. A lot of you are saying don't touch it and make sure it's not lying around. Anonymous, if you touch an insulated wire, you will get shocked. Also, if you touch wire with wet hands. Very good. Maklodi says, and that is why there are no plugs in the bathrooms. 100% correct. You will not find plugs in the bathrooms. You definitely will not. And I mean, in the kitchen, you won't find the plugs near, you won't find plugs near the basin, sorry, the sink, right? So, all right, rubber band, insulator. Thank you, Yovu. Shakira, insulator. Karabo, insulator, 100%. Right, what about the next one, guys? What about cardboard? Right, I'll just wait for those answers to come in. All right, so cardboard is also an insulator. All right, what about a coin? Like your 5 Rand coin, your 50-cent coin, what about that? All right, I see a lot of you saying that it's an insulator. Very, very good. Cardboard is an insulator. I see someone asking me, I saw something about jewelry, I missed it. Oh, there we go. Bounde. Ma'am, will a person get struck by lightning if they are wearing jewelry? Now, jewelry obviously does carry metal object. It is metal, so it will attract lightning, all right? And could be just a little strike. And obviously, depending on how much you wear. I mean, if it's just a ring, possibly not. But I mean, if you're just wearing a whole lot of jewelry, the chances are very, very high. All right. Mahuma, where does lightning come from? Right, so lightning is actually from electric currents that take place when friction happens, all right, just up there. So basically all that friction that takes place and the current causes the lightning to come down from what we call the sky coming down into the earth, all right. So coins are conductors. What about a piece of wood? Very good. Coins are conductors. A lot of you are saying conductor. Awesome stuff. What about a piece of wood? A piece of wood would be considered to be an insulator. And what about aluminium foil? What about aluminium foil?
Teacher, we've got 4 minutes to go.
All right, got it. Thank you very much. Aluminium foil. All right, an insulator. Aluminium foil is an insulator. Sorry, a conductor. All right, aluminium foil is a conductor. We do know that aluminium is not as good as copper, just like we've read in the previous slides, all right, making it a conductor. All right, so we still do have a couple more slides to go. So based on time, I think we can always just stop here, and we will definitely carry on tomorrow, because I do not want to rush this work, because you guys really need to fully understand. So with just the 2.5 minutes left, just please, if you've got any questions, please do ask. I'm just going to quickly go to the last slide for you. Sorry, guys. There we go. All right. So for any questions or any more information, please just email me on karabo@africateamgeek.onmicrosoft.com. All right. So we will carry on tomorrow with exactly where we left off. Reason being, I do not want to rush the rest of the content. Right, so there is no homework for today, thank goodness. But for those of you who want to try and draw your circuit for your home and all the light bulbs, you can just send those through that email. All right, thank you guys so much for being a part of this lesson today. Sorry we couldn't get through all the slides. It was a bit of a lot of information, but we will definitely carry on tomorrow. So please do tune in tomorrow. Nonetheless, have a good day, and I'll catch you guys tomorrow. Bye, everybody.